guys, this is Right On Academia, and today we are looking at the change of base law on logarithm. Okay, we are still on our series of on logarithm. So if you've not watched our videos, please do well to do so. Okay, we've dropped videos on the introduction to logarithm, the addition law of logarithm, subtraction of logarithm, and the power law of logarithm. Okay, so we're going to be looking at the change of base law today. All right, so the change of base law, we're looking at how we can change from a particular base, okay, to another base in logarithm. All right, like let's say given log a base x, all right, I want to change from this, let's say you want to change to base 5 or any base at all. What we do is we take the logarithm of the whole number in the new base and divide it by the logarithm of our base in the new base. Okay, now what I mean is this: if we want to change this, let's assume to base 5 or base n. Okay, let's say base 5. So we're taking the logarithm of a in our new base, which is 5, and dividing it by the logarithm of our base, okay, which is x, okay, in our new base. This is how we do our change of base. Okay, this is how it works. So we make even the base a new log, all right, and we divide like this, all right. So, and at the same time you can also reverse this. When you see that logarithm are dividing each other and their base are same, you can as well as reverse it. Okay, so I'm going to take an example. We have given to us, we have log 32 base 4 plus log 16 base 2 minus log 64 base 8. All right, now we can work this out using our power law like we did like we have seen in our previous video, but for the sake of change of base, okay, we're going to be changing our bases. Okay, like now we're going to be using our smallest base, which is base 2. So we're going to be changing all these to base 2, all right, so that we can work out in the same base. Now we're going to be doing it together. Like we said, when changing to a new base, you take the logarithm of the whole number in the new base and divide it by the logarithm of our base in the new base. Okay, so what we'll be having here will be log 32 in base 2, right, divide by log 4 in base 2. This is how we are going to divide. Okay, so I'm going to keep this in our brackets so that we don't get confused. Let's plus, all right, this is already in our new base, so it will just be log 16 base 2. Okay, and then for the other one we are having log 64 in our new base 2, and dividing it by log 8, right, in base 2. Let's also keep this in bracket. Okay, now we are going to be working it together, and then right now we can use our power law, right. We are going to express 36 using our power law, 32 using our power law. So we'll be having log 2 raised to power 5, right. 32 is 2 raised to power 5 in base 2, divided by 4 is also 2 raised to power 2 in base 2, right, still in brackets, plus we can express 16 as 2 raised to power 4 in base 2, right, and then for the last one we'll be expressing it as log 2 raised to power 6 in base 2 divided by log 2 raised to power 3 in base 2. All right, and so let's continue. Let's work on this like we did in our power law, right. We'll take the power from our whole number and multiply, since the power is for the whole number, multiply by the entire logarithm. So we'll be having 5 log 2 base 2, right, divide by the same thing happens here, 2 multiply entire logarithm, we have 2 log 2 base 2, right, and then we are adding to this. Now our power will also multiply, right, so we'll be having 4 log 2 base 2, and then for the last one, when our power moves, we'll be having 6 log 2 base 2 divided by this, will be having 3, right, 3 log 2 base 2. All right, so we can work on. Now we have log 2 base 2, and like we say, logarithm of the same base is equal to 1, right, so we'll be having 5 over 2 because this is all 1, and then plus 4, and then we have plus 6 over 3. Okay, now we can make this over 1 so that we can have a fraction, right? Then we can get our LCM, which is 6. Okay, and then we can work with this. 6 divided by 2 give us 3, and we have 15, we have 24, and then we have 12. Sorry, minus, the last one is a minus. Alright, and then we have minus 12. Okay, minus 12. Alright, so we have 15 plus 24. That will be giving us 39. Right, 39 minus 12 will be giving us 27 over 6. And this will be giving us 4.5. Alright, so this I'm showing us several ways we can work out our logarithm equation. Okay, now for our second example, we are going to be taking so for our second example, we are going to be taking log 16 over log 32. Now, in this case, like you can see, there is no base given for both. So it is assumed, like I said, when there is no base given, it is assumed that that logarithm is in base 10. Okay, it is accepted that that logarithm is in base 10. So right now, it means they are both in base 10, okay, and we are asked to divide. Alright, now if you don't want to divide in base 10, you can actually do it this way. You can divide in this way. But if you don't want to divide in base 10, you can also use our change of base law. Okay, now since they are both in base 10, alright, it means you can compress this to become log 16 base 32. Alright, where our logarithm, this is the whole number, and then the logarithm for the base becomes our base, like we did in our first section. Alright, so when we get log 16 base 32, we can just work this out using our simplification method. Okay, we'll be having 2 raised to power 4 for 16 and 2 raised to power 5 for 32. Alright, and then when we work this out, like I said, when the power is for the whole number, you multiply it by the logarithm, right? And then when the power is on the base, you take the reciprocal, that's 1 over 5 times the entire logarithm, 2 base 2. Alright, logarithm of its own base is 1, so we'll be having 4 times 1, 4 over 5. So this is our final answer. And with this, we have come to the end of our series on logarithm. Do well to subscribe to our channel if you've not, share our videos, like our videos, and we'll see you in our next class. Thank you.